In this video, we're going to practice with position, distance, displacement word problems. So let's go ahead and get started. Number one, an ant starts at 2 meters. So as you can see, the ant is located at the 2-meter mark. And it crawls forward 7.1 meters. So we know that it goes forward 7.1 meters. Forward also is positive. So positive 7.1. Then it turns around and crawls back 5.5 meters. And back is a negative value. All right, so first, if you're a visual person like I am, I like to kind of draw on my number line a picture of what's actually happening. So the ant starts at the 2 meter, and then it goes forward 7.1 meters. So if you add 2 and 7.1, the ant goes a total of 9.1 meters forward. So it has now reached the 9.1 meter mark. Then it crawls backwards 5.5. So it goes backwards 5.5. It's going to bring us back all the way to 3.6. So about right here. Okay, so what's the ant's initial position? So initial position is just where it starts. Well, it started at the 2 meter mark. So initial position is represented by xi. Our next question, what is the ant's displacements? So it moves twice, right? So the first displacement, d1, it says that it moves 7.1 meters east, or a positive 7.1 meters forward. Our second displacement, the ant crawls backwards. So our second displacement would be 5.5 meters west, or negative 5.5 meters. Our third part, what is the ant's final position? So where does the ant end up with? And remember, we do have this formula to help us actually solve for this. So we should have the final position equals the initial position, which we already wrote down, plus the displacement. And we have 2 displacement values that we would need to add together. So if we set it up, we have 2 plus 7.1 minus 5.5, because remember, we were going backwards at that point. All right, once you do the math, you should be getting 3.6 meters. That's the final position. All right, our last part, what is the ant's distance traveled? Now remember, distance is every step of the journey. You add everything together. So to find distance, you would add 7.1 plus 5.5, and you should get 14.6. All right, let's look at number 2. A boat sails 50 kilometers north, then 800 kilometers south. So I'm going to draw a little picture of a horrible boat. And it says that the boat goes 50 kilometers north. Then it travels 800 kilometers south. So probably proportionally even further than that, but that's all we have for now. So as you can see, the boat ends up more south than it started. What is the boat's initial position? So remember, if the problem doesn't tell you a specific initial position, you can assume that it's 0. So xi equals 0. What is the boat's displacement or displacements? And in this case, we do move twice, so it's 2 of them. The first one, you move forward or north or positive 50 kilometers. For the second one, it would be a negative 800 kilometers because it's in the opposite direction, south. Part 3, what is the boat's final position? So remember, we have this formula that we can use to solve for final position. Once we plug everything in, we should get negative 750 kilometers because our initial position was 0. One displacement was 50, and that one was positive because it's north. And then one displacement was negative. The 800 south would have been negative. So once you do the calculations, you should get 750 kilometers, negative or south. Now, what is the boat's distance traveled? The distance traveled would mean that you add everything up. It travels 50 kilometers one way, 800 the next way. So the total distance of this boat's journey would be 850 kilometers. Number 3, a robot car starts at 50 meters east. So starts at 50 meters east. That's important. Then moves further east. So it moves further east by 200 meters. Finally, the car turns around and moves 600 meters west. All right, so it tells us our initial position. The car starts at 50 meters. And technically this is east, or you can have a negative 50 meters. Now, what is the car's displacements? Well, one displacement was a positive 200 meters because it goes east, which is considered positive. The other displacement would be negative 600 because it's moving west, which is negative. All right, we need to solve for the final position. So again, we can use this formula. So the initial position plus the displacements. So our initial position was 50 plus a positive 200 plus a negative 600. So we should be getting negative 350 meters or 350 meters west. All right, what is the distance traveled? So remember, distance, you add everything up. We went 200 one way, 600 another way. That's a total of 800 meters being traveled by this robot car. Number 4, a woman starts at position negative 10 and has 3 successive displacements of negative 5 meters. What is her final position? Again, if you would like a visual, you can draw your own number line. And we are starting at negative 10. So this is our starting point. It says that we have 3 successive displacements of negative 5. So the pattern is negative 5. So we can count back by negative 5. So we would have a negative 15, negative 20, negative 25, negative 30. And we want to know the final position. So after 3 successive displacements. So if we're starting here, this would be 1. This would be 2. This would be 3 displacements. So negative 25 should be our final position. Number 5, what displacement moves an object from a position of 25 meters to a position of negative 15 meters? All right, so we're looking for displacement, right? So D equals something. We know that it goes from a position. That means that the initial position, xi, is going to be equal to 25 meters to a position of negative 15 meters. So that means the final position is negative 15 meters. And remember our formula that we've been using. The final position is equal to the initial position plus the displacement. So let's plug in and then solve for displacement. So our final position was negative 15 meters. Our initial position was 25 meters, and then plus displacement. So we need to solve for D. In order to do that, we need to get D on a side by itself. So right now we have a positive 25, so we need to subtract so that way it cancels out. And what we do on that side, we definitely have to do to the other side. So our displacement should be negative 15 minus 25, which would give us a negative 40 meters.